All right, can you see and hear?
Yes.
Yep.
Yes. Okay, thanks, guys. All right, so today is kind of another unit in a day. We're going to do maximum and minimum problems this morning, and then optimization, which is kind of an offshoot of maximum and minimum problems. And that we're just going to spend one day on that. So like a little mini unit of word problems. So this morning's should be pretty straightforward after yesterday. So we're learning to find the maximum and minimum values of a function over a given closed interval. The maximum or minimum of a function over a specific interval then, so if it's over a specific interval, will either be at a local max or min or at an endpoint, okay? And local maximums and minimums occur where the slope of the tangent is equal to 0 or the tangent is horizontal. So I did some diagrams. So here's an example of a function over a closed interval a, b. And you can see that the maximum value happens to be at a local maximum where the tangent's horizontal. But here's an example where over that fixed interval, the maximum ends up being at an endpoint. Okay? Not where the tangent's horizontal, but at one of the endpoints. Same thing for a minimum. In this case, the first case, the minimum occurs at a minimum value, occurs at a local minimum where the tangent's horizontal. And in this case, the minimum over the closed interval occurs at an endpoint, lower than local minimum. Okay? So a function f of x is differential. If a function f of x is differentiable over the interval, closed interval a to b, then to find its maximum and minimum values, you would find all values of x where the tangent's horizontal. Okay, so where tangent is horizontal, and then find the corresponding y values at those places of x, where those critical x values. So in other words, we're checking the local maximums and minimums. Then we're also going to find the two endpoints. The endpoints would be f at a and f at b, check those. And then from that list, from those 4 or 3, however many values there are, determine the overall minimum or smallest y value and the overall maximum or largest y value. Okay, and then sometimes they'll fit it into a word problem and you'll have to answer the question that's involved. So we're checking any local max and mins that there end up being, and then we're checking the endpoints. So here's an example. Find the extreme values of this function over the interval -1, closed interval -1 to 5. Okay, so first thing I would do is find f prime at x. And put it into factored form if I can. So I can factor out -6x. Set it equal to 0, which will give me the places where the tangent's horizontal. And then solving for x here, we can see the tangent's going to be horizontal at x equals 0 and x equals 3. So we want to find the corresponding y values that go with x equals 0 and x equals 3 because those are the two spots where the tangent's horizontal in this function. And another thing to notice is that they both fit into this interval -1 to 5. So you always have to check and see whether the x values you get are contained within the interval you're testing within. Okay, so we're only worried about the values of this function between -1 and 5. So if I'd have gotten that the tangent was horizontal at x equals -3, for instance, I wouldn't test that one because it's not in the interval I'm looking at. Okay, but in this case, 0 and 3 both happen to fall within that interval. So usually when I'm organizing my question, I'm either going to write, I usually say test. I call them peaks and valleys or hills and valleys. Max and min is fine as well, max, mins. Local extrema you could use, however you want to describe that you're testing those values. And then you're going to find them. So f at 0. So remember, I'm going back to my defining equation. You can just see that that's going to be 4. That's easy. F at 3. Is going to end up being 31. Okay, and then over here, we're going to test the endpoints. So we're going to find f at -1. There's one endpoint. So that's going to be 2 plus 9 is 11 plus 4 is 15. And f at 5 is going to be -21. So now in this case, it wants the extreme values. So it wants the largest and smallest values out of these 4. And so my largest one is 31. And my smallest one is -21. So look at all of them and then answer the question. So find the extreme values. So the maximum value of f at x equals -2x cubed plus 9x squared plus 4 over this interval is 31. And the minimum value of f at x equals -2x cubed plus 9x squared plus 4 over this interval. Oops. Is -21. So find the extreme values, so we find the largest and smallest values of that function over that interval. And that's how you do it.
Do we have to rewrite the maximum value of f at x, you know?
No, you could just write, you could just kind of box up these. As long as you've shown all your work, you can write the maximum value is 31 and the minimum value is -21. I'm just trying to be really specific because it's the first question we've gone through today.
Okay. Awesome.
Okay. Yep. All right, so the next one is still very similar, but now there's kind of a little word problem context to it. So the amount of current in amperes in an electrical system is given by the function C at t is -t cubed plus t squared plus 21t, where t is the time in seconds and t belongs to the closed interval 0 to 5. Determine the times at which current is at a maximum and minimum, and determine the current at these times. So it's asking for two things here, not just what the maximum and minimum current is, but when they occur, which will be the t, corresponding t values. All right, so again, the first thing we're going to do is find c prime at t. So there we go. And then factored form here. So I see that there isn't a common factor. So let's see if we can factor this trinomial. So if it would be a complex trinomial, I'd be looking for two terms that multiply to negative 63t squared and add to 2t. And I think they're 9t and negative 7t. So negative 3t squared has more in common with positive 9t than minus 7t plus 21. So I decomposed the 2t into positive 9t and negative 7t. If your decomposition is a little rusty. And then common factor, the first two terms, negative 3t is in common. And then the sign that comes next goes next. 7 is in common. Negative 7t divided by negative 7 is t. 21 divided by negative 7 is negative 3. So then t minus 3 becomes the binomial common factor, and negative 3t minus 7 is the other factor. And then we want to set that equal to 0. And solve, and that would be where any peaks or valleys or local max and mins are. So t equals 3. This one's a bit trickier. So we get t is negative 7 over 3. Remember, this represents a time, but also it's not in this interval 0 to 5. So because it's not in that interval, we're going to not test that one. Okay, we're only going to test the one that is in the interval 0 to 5. So I'm going to come up here and test peaks or valleys, or local max mins, whatever you want to write there. And the only one we're going to test is 3, so we're going to find c at 3. So that's going to give us negative 27 plus 9 plus 63, 45. And then we're going to test endpoints. So we're going to find c at 0, which is 0, it's easy. And c at 5. Which I got 5. Okay, and we want to know the times at which current is at a maximum and minimum and determine the current at these times. Current is in amperes, so these are amps. And these are the times here, and they're in seconds. So the minimum is going to be here, smallest amount of amps. And the maximum is going to be here. So then our therefore statement will be the maximum of 45 amps occurs at t equals 3 seconds, and the minimum of 0 amps occurs at t equals 0 seconds. So this one was important because it showed us where we got one of those critical values that wasn't in the interval, so we didn't go ahead and test it. So watch for that. And then also make sure you answer the question they asked, because they asked us for determine the times at which current is a maximum and minimum, and determine the current at these times. Okay. So a flu epidemic breaks out in Mathville. The function of the population that is infected at time t in weeks is given by that function. Determine the maximum fraction of the population that is infected over the first 10 weeks. So we just want the maximum, in this case, of the population infected over the first 10 weeks. So the closed interval is 0 to 10. So the first thing that I would want to do would be to find f prime at t. But this is a quotient rule, so it's going to take me a little more work than just the power rule, like the first two examples. So I'm going to do my first, second function derivative. So the derivative of 64t is 64. And this one involves the chain rule, 3 times 8 plus t to the power of 2 times 1, which is just 3 times 8 plus t to the power of 2. Remember, we're using the quotient rule. So that's going to be derivative of the first times the second, minus the first times the derivative of the second. So I'm going to multiply the 3 and 64t together. So it's going to be minus 192, 192t, 8 plus t squared, all over the second, 8 plus t cubed squared. And because we want to set it equal to 0 and solve, it's definitely good to simplify it as much as possible. So we want to look for our common factor. So 64 goes into 192, so 64 is going to be part. And 8 plus t to the power of 2, that's my common factor. And then if I divide the first scoop by the common factor, I get 8 plus t. And then if I divide the second scoop by the common factor, I get minus 3t all over, that's going to be 8 plus t to the 5th. And then we've got...
Won't that be to the 6th?
Thank you, John. Thank you. 8 plus t to the 6th. And then we've got powers with the same base in the numerator and denominator. So f prime at t is 64 times 8 plus t to the negative 4 times 8 minus 2t, which I can rewrite as 64 8 minus 2t over 8 plus t to the 4th. I could factor 2 out of here, but I'm solving. I'm going to set it equal to 0 and solve, and that's not going to be too much of a big deal. So I think I'll just set it equal to 0 now. So, do you guys agree that if I multiply both sides by 8 plus t to the 4th, that divides out my denominator on this side, and on the left side, it's still equal to 0, because when you multiply anything by 0, you get 0. And then I could divide both sides by 64, or I can just use an arrow at this point. I know 64 times that has to equal 0 is only true if 8 minus 2t equals 0. 64 can never be 0. Add 2t to both sides, and you end up getting t equal to 4. So that's the only place where we could have a peak or valley. So we'll check that now. I'm going to come up here. So I'm going to find f at 4. Oh, first I'm going to make sure 4 falls within my interval, which it does. It's between 0 and 10. So I'm going to find f at 4, which is 64 times 4 over 8 plus 4 cubed, which is 256 over, that's going to be 12 cubed. See if that reduces. I think they divide by 16 anyways. Maybe 64. Let's see if they divide by 64. Yeah, divide by 64. So that gives us 4 over 27. And remember, the question said determine the maximum fraction of the population infected over the first 10 weeks. So there's a fraction, 4/27ths of the population in week 4. So now we're going to check endpoints. So we want f at 0, which is 0, and f at 10, which is 64 times 10 over 8 plus 10 cubed. And see if we can reduce that. And divide by 8. over 729. And then we have to see which one of these fractions is bigger, so you can just try them out as decimals. 4 over 27 is about 0.148. 80 over 729 is about 0.109. So this is the largest fraction. Okay, so that's approximately 0.148. And this is approximately 0.1097. And then make sure you answer the question, determine the maximum fraction of the population infected over the first 10 weeks. So therefore, the maximum fraction of the population infected is 4/27. So that one was a bit tougher because we had to use the quotient rule. We had to then set it equal to 0 and solve, realizing we could multiply both sides by the denominator. To get our critical value of 4, made sure it was in our interval 0 to 10, tested it, then tested the endpoints, found the maximum because that's what they asked for, and then did our statement. Okay, and question 4. The predicted population in millions of a small country is modeled by that function, where X is the number of years since 2001 and X is in the interval 0 to 30. Determine in which year the maximum population occurs. Or sorry, minimum population occurs. So the question is determine in which year the minimum population occurs. So the first thing we want to do is find P prime at X. Maybe we want to rewrite it first. Maybe I'll just rewrite it. So just rewrite P at X so that it's 1/400th X squared minus 1/10 X plus 5. Many of you probably don't need to do that, but just in case. So that's going to be 2 times 1/400th, which is 2/400ths, which is 1/200th X minus 1/10. And then we want to set it equal to 0. Solve for X, so I can add 1/10 to both sides. Multiply both sides by 200 to get X by itself. So 200 times 1/10 is 20. So X is 20 is our critical value. And then we're going to check and see, is 20 in the interval 0 to 30? Yes, it is. So we can test it. So test. So P at 20 is equal to 20 squared over 400 minus 20 over 10 plus 5. So that's going to be 1 minus 2 plus 5 is 4. And then we're going to test endpoints. So we're going to find P at 0, which is 5, and P at 30, so that's 900 over 400, or 9 over 4, minus 3 plus 5. What does it want? Minimum population, so I can probably do it as a perfect decimal here. So 4.25 exactly. So we're looking, determine in which year the minimum population occurs. So the minimum is 4. But it asked in which year. So year 20, but it's since 2001. So that means 20 years after 2001, which is this year, 2021. So therefore, the minimum population will occur in 2021. Any questions? Okay, our success criteria then for this lesson are define the maximum and minimum values of a function over a closed interval, solve problems that involve finding the maximum or minimum values of a function over a specified interval, and understanding that local max and mins occur where the slope of the tangent is equal to 0. Okay, so I'm gonna stop the recording and then Miss Martin and I are gonna talk to you about the summative assessment for calculus. And I'll start a new recording for that because there's a couple of students that messaged me that they couldn't get on. So they'll probably want to hear that. Stop recording.